All right, folks, welcome back to Precalculus. This is Chapter 6, Section 4. We're playing with double angle, half angle, product to sum, sum to product identities. Essentially, we're using more identities to solve. What you're looking at on the front of your notes are the remaining identities that we have for this section. I'm not going to go through every single one of them, but rather reference them when it's time to use them, and we'll come back to them. Okay. So let's dive right in. So first things first, we're being asked to find the sine of a double angle, cosine of a double angle, and the tangent of a double angle given the tangent of a single angle. Okay, and that angle is in quadrant 3. So really quick, we're drawing our attention to here, here, and here. Okay, we're going to find a creative way to do that tangent one here in a second. But knowing that this angle is in quadrant 3, I'll just draw a little picture up here of a quadrant 3 angle. Tangent is 13 over 84, so opposite over adjacent, negative 13, negative 84, quadrant 3. Little Pythagoreans will tell you that the hypotenuse is 85. Okay, now sine of a double angle, if you reference your table on the front, you'll see is equal to 2 sine of that single angle, cosine of that single angle. And it's as simple as looking at our picture here. So sine, opposite over hypotenuse, negative 13 over 85. Cosine, adjacent over hypotenuse, negative 84 over 85. Negative times negative is positive, and if we multiply all that out, top and bottom, you should be getting 2,184 over 7,225 as your answer. As simple as just plugging and chugging. So when we go do cosine of a double angle, it's the same thing. You actually have 3 equations to pick from. Doesn't really matter which one you pick from. You're going to be squaring and stuff like that for all of them. So I'm just going to go ahead and choose the first one and use cosine squared x minus sine squared x. And again, referencing our angle here, the cosine was negative 84 over 85, so that's going to be squared. And the sine was negative 13 over 85, that's also going to be squared. With a special note that exponents before addition, subtraction, so this negative sign in the middle is not going to cancel out because this is going to end up being positive. And when you do that, you should get 6,887 divided by 7,225. Really simple and straightforward. Now for tangent, there is an equation for it for a double angle. I'm not going to make you guys use that. If you recall the definition of tangent is sine over cosine. Okay, so I can just take these values that I got for sine for cosine, put them over each other. So I got 2,184 over 7,225 divided by 6,887 divided by 7,225. My denominators cancel, and I'm left with a tangent of 2x is equal to 2,184 over 6,887. Really simple. Okay, moving on. Using a double angle to find single angles now. So kind of going backwards. So what we're going to say is, like, if our double angle is in quadrant 4, then that must mean that my single angle is in quadrant 2. Okay, when I'm solving for sine, cosine, and tangent, meaning I should get a positive sine value, a negative cosine value, and a negative tangent value. Okay, and it's just a matter of using the equations on the front. So cosine of a double angle, I'm going to go ahead and use the one that only has sine in it to solve for sine. So 120 over 169 is equal to 1 minus 2 sine squared x. Really, really simple. So now it's just a matter of isolating sine by itself. So we're going to have to subtract 1. I'm going to go ahead and move my 2 sine squared over to the other side and move this 120 over 169 to the right side. So I'm going to end up with 2 sine squared x is equal to 49 over 169. Remember that 1 is 169 over 169. Divide by 2. I'm going to end up with sine squared x is equal to 49 over 338. Square root the top and bottom. Square root of 49 is 7 over radical of 338. We can rationalize that really quick. Move the radical to the top and remove the radical from the bottom. Okay. Noticing that when I square rooted, I should have got a plus or minus, but because I know I'm in quadrant 2, because my double angle is in quadrant 4, my sign value should be positive. Okay. The same is true. I'm not going to show you, but for cosine and tangent, again, to find cosine, I would just be using this equation right here, 2 cosine squared to minus 1, and set that equal to 120 over 169. And then to find tangent, I would just take my sine and cosine values and divide them. Really quick, fast, and easy. Okay. So now we're going to rewrite each expression in terms of only cosines to the first power. So essentially, we are going to power reduce. Okay, so we're going to use this equation right here. So we know that sine squared is equal to 1 minus cosine of 2x, over 2. And because this is sine to the 4th power, I'm just going to square it. And cosine squared is equal to 1 plus cosine of 2x over 2. Both those things pulled from the front in our power reduction table. Nothing crazy. I'm done. Okay, cosine of the first power. So like I just said, sine squared was equal to 1 minus cosine of 2x over 2. And because this is sine to the 6th, this is going to be to the 3rd power. Sine squared to the 3rd power is sine to the 6th. I'm done. Okay. All right, let's get into something a little bit more difficult that isn't just plugging and chugging. Trying to find the sine, cosine, and tangent of an angle that is not a special angle on our unit circle. Okay, we've done this a little bit with sum and difference, but now we're going to do it with our half angle identities. Okay, with our half angle identities, and specifically this one's first because it's sine. So to find the sine of 3 pi eighths, all right, the sine of 3 pi eighths, I know that that's the exact same as the sine of 3 pi fourths divided by 2. And the reason why I'm choosing 3 pi fourths is because that is an angle that is on a special angle on my unit circle. It's a quadrant 2 angle. I know a lot about that. We know a lot about that, and we'll be able to do a little plug and chug pretty quickly. Okay, so we can substitute in our half angle identity for sine, plus or minus radical of 1 minus cosine of the angle. So that'll be where I plug in 3 pi fourths, all divided by 2. So plus or minus the square root of 1 minus cosine of 3 pi fourths divided by 2. Okay, the first thing I'm going to address is this plus or minus. 3 pi eighths is a quadrant 1 angle. It's a little bit less than 4 pi eighths, which means it's in quadrant 1. So I know that my sine value is going to be positive, so I'm going to stop writing plus or minus. I'm now going to evaluate what is the cosine of 3 pi fourths. Well, that's negative radical 2 over 2. That keeps breaking. Negative radical 2 over 2. So that's going to turn this negative sign here into a positive sign. I know that if I want to simplify the numerator, I better have common denominators, so I can rewrite my 1 as 2 over 2 and divided by 2. So really simple here. On top, I get 2 plus radical 2 over 2 divided by 2. And just to show you the algebra behind it, anytime you take a fraction divided by 2, it's the same as taking that same fraction and multiplying it by 1/2. So I end up with the square root of 2 plus radical 2 over 4. And if I distribute my radical, I end up with 2 plus radical 2. Sorry, my radical's a little bit too big there. All divided by 2, because the square root of 2, or of 4, the square root of 4 is 2. Okay? Awesome. So moving on now. Well, let me just say really quick that evaluating the cosine and tangent is the exact same. Okay, you should be doing that on your notes. Find the cosine using the half angle identity for cosine, which you can find right here. And then it's as simple as taking your sine value divided by your cosine value, and you'll get your tan value to find the tangent of 3 pi 8. So moving on. Trying to keep things short and simple for you guys. We're trying to find the exact value of sine of a half angle, cosine, and tangent. It's the same thing, same process. Okay, we're going to find sine. It's going to be the exact same process to find cosine, and then you can take sine over cosine once you have those answers and get your tangent answer. But given that we are given the tangent of an original angle, okay? So if we are given an angle in quadrant 2, okay? We're given an angle in quadrant 2. Okay, tangent is opposite over adjacent, so this will be 35 over negative 12. Okay, we can do some quick Pythagorean and figure out that our hypotenuse is 37. And if I'm trying to find the sine of a half of that angle, okay, first of all, half of an angle in quadrant 2 is going to end up being an angle in quadrant 1. All right, so they're all going to be positive. Your sine, your cosine, and your tangent value all are going to be positive in quadrant 1. No matter what you get your answer here, because you're cutting this angle in half, you're finding the sine, cosine, and tangent of an angle that somewhere about right there. Okay, they're all going to be positive. So we know that this is the square root of 1 minus cosine of x over 2. Cosine of x, looking at our triangle, is adjacent over hypotenuse, negative 12 over 37. So that's going to turn my minus sign into a positive sign, 12 over 37. And I'm going to decide to turn my 1 into a 37 over 37, just so I have common denominators. And we're still dividing by 2. So we get a square root of 49 over 37, all divided by 2. Like we just talked about in the last problem, dividing by 2 is the same as multiplying by 1/2. So I'm going to get the square root of 49 over 74, which is 7 radical 74 over 74. Of course, it's going to be positive. I don't have to mess with the plus or minus because I know that half my angle is going to end up in quadrant 1. Okay, the same can hold true. You should do this on your notes, is finding the cosine. You're just using the cosine half angle identity again, which is right here. And then you can take your sine value and your cosine value and put them over each other to get your tangent value. Okay, rewriting this in terms of or reducing the product to sum, we are going to be looking at this one right here, because I noticed that my problem that I'm looking at has 2 times sine of an angle, which is the exact same as this one right here. Okay, now I have a 2 right here in my problem, and this one does not. So that we'll just have to imagine that I multiplied both sides by 2 for the sake of using this identity, which would get rid of that 1/2. Okay, so 2 sine of 5t over 2 times the sine of 9t over 2 is going to be equal to the cosine of alpha minus beta minus the cosine of alpha plus beta. Okay, with my alphas and betas being here. Okay, it's not really going to matter which one is which. For the sake of this subtraction right here, I'm just going to go ahead and make my alpha the bigger one. So let's say cosine of 9t over 2 minus 5t over 2 minus the cosine of 9t over 2 plus 5t over 2. And just a quick simplify, common denominators, 9 minus 5 is 4, over 2 is 2, so this is going to end up being the cosine of 2t minus the cosine of 9 plus 5 is 14, divided by 2 is 7, minus the cosine of 17. Moving on to our last one, we are working with a sum to product, and if you look, we have a sine of an angle plus a sine of an angle, so that's going to be this one right here. Sine of u plus sine of v is equal to this big thing right here. We're simply plugging in u and v and simplifying. Okay, so our u is 11 pi twelfths and our v is 7 pi twelfths. So the sine of 11 pi twelfths plus the sine of 7 pi twelfths, using the identity from the front, is equal to 2 times the sine of 11 pi twelfths plus 7 pi twelfths, all divided by 2, times the cosine of 11 pi twelfths minus 7 pi twelfths, all divided by 2. Okay, now it's just simplification time. So 11 plus 7 is 18. So we got 18 pi twelfths, all divided by 2. And cosine 11 minus 7 is 4 pi twelfths, all divided by 2. And like we've been talking about a couple times this lesson, dividing by 2 is the exact same as multiplying by 1/2. So this is going to turn into 2 times the sine of 18 pi 24ths times the cosine of 4 pi 24ths, which puts into lowest terms the sine of 3 pi fourths times the cosine of pi sixths, which both those are angles on the unit circle, special angles on the unit circle we should know. So we got 2, the sine of 3 pi fourths is positive radical 2 over 2, and the cosine of pi 6 is positive 3 radical 3 over 2. This 2 and that 2 can cancel out, leaving us with a radical 6 on top divided by 2 as our answer. And that's it. You see your homework at the bottom. If you're not in the homework club, you'll need to do that homework, but there's more details in the description of this assignment. Thanks, and I'll see you guys tomorrow.